Good afternoon, everybody, and welcome to the third edition of the Rise of IoT and Big Data and Rail virtual workshop. For those that don't know me, my name is Ben Holliday, and I'm the Managing Director of Rotea Media, the organisers of today's event. I'd like to start off by thanking each and every one of you for registering to attend today. You'll be interested to learn that today's attendance is our highest audience that we've attracted for one of these workshops. So thank you once again for your interest. A special thanks goes to our speakers for today, as well as our workshop moderator. Without all of your support, today wouldn't have been possible. So thank you once again. As many of you know, at the end of May, we'll be running the main event of the Rise of IoT and Big Data and Rail conference. Over the course of the next coming days, I'll be announcing a few developments for the event via email as well as on LinkedIn. So please keep your eyes peeled for those. And of course, I look forward to meeting many of you at the event itself. All it leaves me to say is thank you once again for your participation today. I hope you enjoyed today's session. And I'd now like to pass you over to our moderator for the day, Daniel McGregor, the co-founder from the company Nexia. Many thanks.
Hello, Ben. Hello, everybody. Thanks very much for your nice introduction. As Ben said, we're meeting here again online. It's wonderful that so many people could join us. I think we had over 700 people registered, and most of those people are actually joining the event today. So a very big special thank you to Rotea Media for this event and for all these events in this Rise of IoT and Big Data in Rail theme. We'll today be optimizing or looking into optimizing the IoT to exploit smart asset data to improve network availability and extend asset lifetime, and hopefully also to reduce costs. So I extend a warm welcome to all of you. I'm grateful for this opportunity. It keeps our collective digitization efforts on track. We have another excellent lineup of speakers, and I know it's going to be a fascinating session. A quick introduction from me. I'm Daniel McGregor. I'm the co-founder of Nexia. We're a leading enabler in digitizing the supply chain. We focus on collecting data from rail freight wagons and other mobile assets in the supply chain. And we leverage this to create improved performance for our customers, to create new services and for data-driven value to them and their cargo owner customers in turn. As a community, we've spent the last 5 years scoping the IoT and big data in rail, and we've made and continue to make some fantastic progress. We can take different perspectives, and we'll engage in some healthy debate today. We'll focus on network availability, and we'll look into extending the asset lifetimes and reducing costs. It's important to think about the processes around these critical network components. I spoke already to today's panelists over the last few days, and we expect to get some great presentations and insights from them in turn. We're going to look into what real visibility means and discover what we can actually do with it once we have it. Our panel today is Stefan from DB Nets, Christoph from Plaster and Tura. We have Roland from SBB Infrastructure, Ed from Copperleaf, and Timo from ProRail. And each of them will make a short presentation, and then we'll move into a group discussion after the presentations at the end. So that's enough from me for now. Let's start with our first speaker. The first speaker is Stefan Listner. He's the head of analytics of asset management at DB Nets. Stefan will give us some insights into maintenance and strategy around the current goals, the data platform, and how they're using digital tools to drive predictive forecasting of breakdowns and railroad crossings, and hopefully driving performance up. Let's discover some more from the expert himself. I hand you over to Stefan Listner.
Dan, thank you for your introduction and for the possibility to speak about the German way regarding to the maintenance strategy. First of all, a warm welcome from my office located in Munich nowadays. In the next about 10 to 15 minutes, I'll speak about the current goals and challenges for the German network, CBM with our diagnostics platform Diana, and our first steps into data-driven predictive maintenance, forecasting breakdowns of railway crossings with AI and machine learning. I'll start with some facts and figures about a quick overview of our organization structure at the headquarters in Frankfurt. Here you see many numbers on the right side of this slide. I only want to highlight 3 of them. First of all, you see that we have in Germany a very big network used by mixed traffic. It's highly asset intensive and mostly in the middle or in the end of the life cycle. Let's say our asset is very experienced. Many of them are older than 100 years, especially when I think about bridges and interlocking systems. Even the train load has been and will increase very significantly. Second, 118,000 disorders per year keep us busy 24/7 and are the reason for unpunctionality caused by the infrastructure. Over 90% are caused by interlockings, railroad crossings, and switches. You can say that these 180,000 disorders are 1/3 of all causes for limited capacity. Third, we put between 500 million and €500 million per year sustainably to maximize the effect on availability on our assets. So that's a big challenge in Germany to keep the existing networks available for the future. What I am in charge for, or what are we in charge for? The organization, analytics, and asset management includes 4 business lines, which are responsible for some of the key integrants to increase the availability of the existing network. First, you see ENIE 21. It's the analytics unit. The main task of analytics here is to create transparency about the performance of the network and use modern networks and methods with a view to AI and machine learning. Second, strategy ENIE 22, sorry. The further development of the maintenance strategy and the innovation management based on it. That's very important. We don't want to push innovations which doesn't fit to our main strategy. Third, the lifecycle management. I call it the machine room, which is responsible for building the RAM models for all systems in order to take the right measures in the right place. And fourth, the interlocking program to transfer it from the point of end of life cycle to digitalization. It's a special unit that it's allowed to design the minimal invasive, it's a medicine word, replacement of systems at the end of the life cycle with 1.3 billion euros over the next 10 years. One picture tells it all. Our strategy schematic on this slide. On the left, you see our individual parts of the maintenance budget, which is about 2 billion euros per year. And you see that over 50% of this budget is spent for corrective maintenance parts, and approximately 1/3 is preventive. There we have many actual tasks like e.g. the inspection of the bridges and the vegetation. But, and this is what you see and in the top via diagnostics, it's the first steps of CBM and predictive maintenance in the existing network. On the right, you see where we want to be in 5 to 10 years. Our main goal is to increase CBN and predictive maintenance to decrease the corrective parts. Automatization and remote control is necessary to pay the bill, or last but not least, to steer against the democratic change. So it's very important to keep the focus on the initiatives which consistently serve this goal. So we want to build up and increase predictive parts via analytics and AI, and condition-based maintenance also via sensors and remote control for the cost-saving aspect. I've already talked about our first steps into a chosen future. Here's one which I'm particularly proud of: the forecasting of the railway crossing disorders. We used our data treasure of the 14,000 railroad crossing for a very attractive goal: the data-driven forecast of the future point of disorder and expected impact of operation and punctuality. So we can say which railroad crossing system will be going towards breakdown, and in the next step we want to increase and develop more steps to drill down to prediction of the components, to say which components, for example the battery, will fail in 2023, so we can make the right steps in these months to avoid it. For about 2 years, we used the data prism to improve our prevention programs. So all these informations go to our prevention programs and make it very effectively. The pros of these steps are the data prediction. It's real data based. It's data based from the first and the last years, where the railroad crossing system has produced a disorder, and we can take them to predict the future with modern methods of AI and also machine learning regarding to the effect on the operations. Here is no sensor rollout needed, and it's a small cost, and we like it very much because of that, and because it's better. It's the best way to focus in short times to the right things in our prevention budget. We do many more, I have to say that, and have to extend this. We do many more things in this way, but this is the first initiative which goes to an end, and to switch the predictive maintenance aspect into the regular prevention process. On the next slide, there's a view you probably know or heard about it. In the last year, we connected about 13,000 switch drivers to our platform Diana, Diagnostics and Analytics. We finished this project last year and are earning the rewards now. The decreasing number of disorders: in the last month we avoided about 4,400 disorders, which is about more than 10% of all disorders caused by the switch. You see that on the right side, the right picture. One trend goes up, it's the usage, and the trend which goes down is the faults or the disorders. These successes keep us motivated for taking further steps in this direction, but to be honest, we have to speed up a little bit. So my last slide, to increase our costs, we have to take one more step to reduce the costs, and not only to reach more availability. To decrease costs, it's totally necessary to adapt the rules. Today we have more efforts in the first steps, because the new sensors give new information. We add to the step triggered to the time-based inspections, And we add the step triggered by diagnostics information you see on the left side. And on the right side, you see where we want to be in the next years. I think the flight industry does this very good nowadays. And I think we can do it totally, but it is a way we have to go, and there have to be some final steps to reach this goal. So I would like to finish with my short presentation with a very nice development. In 2020, we decreased the number of these orders by 20,000. About 5,000 each caused by a better performance by railroad crossings and switches. Both initiatives I showed you gained an impact. Let's continue the next steps to the right thing for reliable infrastructure in Germany. Thank you for your attention.
Thank you very much, Stefan. It's really encouraging to hear the progress that you're making, and you know, there's some seriously tangible outcomes already reported. And I think one of the things that impressed me most is how you were able to do so much initially without adding more sensors. And then as you bring additional sensors into the game, you've already got kind of a template for how you will use the data that comes from them. So, you know, it's always the case, like how much can you discover sort of just from the data? Can you get a clue? And then can you make further adjustments to your approach to make bigger advances in the future? I noticed there's still, even though there's a clear trend, there's still quite some variance. You know, you have moments where the number of disorders shoot up rapidly over the short term, but over the long term, you can identify this trend. And I think the first thing is just to say that it's very encouraging to see this performance from the, you know, the initial project outlook. And obviously, we're hoping this will continue and, in fact, increase even sort of more dramatically or exponentially as you go forward. So we'll pick up on some of those topics later. And, you know, I think, you know, it's a great presentation to kick things off because it's some really tangible use cases there with this crossings topic. And also, when you look at the infrastructure that you've implemented this on, it's not a trivial project with such ancient infrastructure. You know, you have such a variety of infrastructure managing old and new, but some of it is really old. And, you know, the complications of that is almost chaotic. You think about weather, you think about all of these different elements, and there's a lot in scope. So, you know, thanks so much for the presentation, and, you know, thanks for that insight. So we'll catch up with you a bit later, Stefan. We're going to move on now. So I'd like to introduce our second speaker. We're going to unlock some opportunities in artificial intelligence and discover how can we can automate repetitive tasks on tamping machines. I spoke to all of the presenters before the event, and we had a fantastic discussion. So I'm looking forward to this presentation now. We're going to look at how we can reduce the risk of damage and increase the quality of the work that's done. And we're going to discover more about measuring the absolute track geometry. And I think it was the first time it was applied to a track that's actually a high-speed track. So this was a real game changer. I don't want to blow all of your interesting presentation topics. So let's move into this one. How do they process the big data that enables an increase in track capacity? I hand over to one of the most capable men in this field, from Plaster and Tour, the head of track analytics, Mr. Christoph Wilczek. Welcome. I'll leave it with you.
Thank you, Daniel, for the kind introduction. So ever since I was a little child, I was fascinated by trains and railways. My grandmother used to take me and my brother to the train station. We imagined how wonderful it would be to get on one of those trains. We would experience adventures and explore the world. Ever since this fascination has guided me through life. And wherever I go around the world on conferences, and especially like conferences like this one, I see people that drive the same passion and have the same passion around railways. And I think it's interesting that railways is spread around the world and it's guided on the same principles, be it heavy haul in Australia, high speed in France, urban rail in Japan, or like in this picture in Thailand. Maybe some of you will recognize this one, but yeah, maybe look it up after the conference and Google it. It's a crazy place. So what connects, or especially from my perspective, what connects railway is the permanent way. Around the world, you see these 4 components that it's made of. It's rails, sleepers, ballast, and subsoil. So if there's one thing that you take out of my speech is that you remember that the permanent way is made up of rails, sleepers, ballast, and subsoil. So every 60 centimeters along the track, there's one structure that supports and guides the trains. In the early days, it was very hard and arduous manual work. Constructing and maintaining required skilled and hardworking people. Nowadays, it is made by automated machines like this one. It's a track renewal machine, or actually, this one is a switch replacing machine. At Plus and Teurer, we introduced technology into track construction and maintenance, and I want to show you how we do this. So from our perspective, or from my perspective, technology is like, it comes in hype cycles and they are like waves. So I'm a surfer, so I like this metaphor, but because when you're in the line and you look for the waves, some waves are too small and some waves are just very big. So you better keep paddling and catch it and ride it, otherwise it will turn your world upside down. So my job and my team's job is to look out for new technologies and to see how we can introduce them. And I guess everyone already knows Gartner's hype cycle, how they came with the innovation trigger, peak of inflated expectation, froth of delusionment, and slope of enlightenment. And so we are trying to pick out the right technologies and see how we can implement them into machines, how they can generate value for the railway industry, and hopefully they will become the standard in the railways. So how we do this? We introduced ourselves. It's a new, not a new concept, but we introduced the technology readiness levels within our company when we talk about technologies. Because sometimes in the beginning it's just an idea, and you want to take this idea through the testing of basic principles, technology concept, experimental proof of concepts, validation laboratory, validation in an environment, and prototype demonstration, and so on, until you prove it that is a qualified system and can use it in best practice. So this is how we approach things. So everything I tell you right now is going through this process. And I think it was first established within the NASA, and it's an interesting approach how to think about new technologies and how our world changes with technology. So I want to show you kind of the unique challenge, or this challenge that we have within the permanent way, and especially IT technologies. There is an unequal service life. So in IT technology, we have a half-life of 3 years. So when you look, for example, at your phone, how often you change it. And on the other side, how long tracks can last in the field. We've seen already that at Deutsche Bahn it's 30 years. So around it's 35. I said 35 years, but it's a round figure. So you see that every time we introduce IT technologies into track, it probably will increase the cost because it's more expensive, and it will demand 10 times servicing while we need just to replace the track once. So we have to be very careful how we introduce those technologies and think about the life cycles ahead. So I would like to show you 3 of my favorite projects that I'm working on with my team, and the first one will be automation, then we go to surveying, and then to compaction. So automation, I don't know, I don't want to assume that everybody in the panel knows how a tamping machine works. So I would like to just take a couple of seconds to explain it. So the tamping machine is used to restore correct track geometry. So imagine that every time a train passes, the tracks and the ballast settles a little bit. And after some years, you need to pull up the rails and sleepers to maintain the smooth ride. So this machine does exactly that. It just takes, so a tamping machine takes the sleepers, pulls it up, and compacts the ballast underneath it. And the operators need to be very skilled to do this. So even slight inattentions might result, as you can probably imagine, great damage to the track and lead to the rails of trains. So to take the burden of the operators, we equipped this machine with a laser scanner, RGB cameras, and line profile sensors to collect information about the surrounding. An artificial intelligence unit calculates the optimal tamping parameters and then sends suggestions what kind of adjustments needs to be done. The operator confirms these recommendations, and I think it's just great to see how much burden it takes for the operators away when you consider that most of this work is done during night shifts, and it's kind of repetitive and monotone work. And I would like to show you a brief video how this works in real practice. So maybe we can start the video, Andrew. Oh yeah. Oh yeah, great. So hopefully you can hear me. Okay, so at the end you saw all the data that was collected as a digital protocol for the proof of work what was done. And I think it's a very interesting development that we have right now. We are developing, so we're delivering further machines to Infrabel, and I'm really excited to bring this product into a real working environment. So the next topic I would like to talk about is surveying. So usually, so this is a measuring vehicle. So usually they're used to measure the track geometry and other parameters to ensure safe and smooth track operation. However, this specific vehicle is our research vehicle. So we use it to test new technologies, new sensors in a working environment. This one reminds me a little bit of the Sentinel from the movie Matrix, but this is my own association. So let's put this one away. Okay, let's see if we can get. So one system that is that we developed for this vehicle is the stereo camera system, from which you can measure the absolute track geometry. And we presented it on at a conference, and one of our partners in Germany thought that might be an interesting project coming up. And the challenge was the following. So there's the track between Kassel and Würzburg, and it's around 180 kilometers of track that needs to be renewed. And the challenge was that the regulation requires that to do a manual survey of the track. So before you renew the complete track, you need to do a manual survey. So it looks like this. When it's good weather and nice conditions, it's a perfect nice job because you get to go outside and see how the tracks looks in real life. But for 180 kilometers of track, this would require a lot of track closure time, especially during daytime. And as you can see, maybe from the topology, that was not an option they wanted to choose. So what we did, we scanned the tracks with our measuring vehicles just in 2 night shifts with all the equipment that you see on top. And we could reduce this time, the 60-day track closure, into just 2 night shifts. And the track inspection was actually done in this room, going through all the data. And the interesting part is not just to look at the video, but we could actually measure all the objects that were required for the track renewal. So it's interesting to see how, with just a little bit of will and trying out how can we save costs, you can come up with such a nice solution. So I would like to come to the third topic, which is actually my favorite one, and I probably think for most people it might be the most boring one. So, but bear with me. I just love this concept. So imagine that you have a box, and you put kind of stuff in there, like a couple of stones. And when you just throw them in there and you shake the box around, then you will see that that everything will settle down to a certain parameter. So let's empty out the box again and just take the box and put all the stones that we have and put them neatly and orderly into the box. And then we'll see that you can align them in a very even lower level. And when you shake the box again, they will come up again. So this is the state how you want actually to do the compaction for your ballast. Because just in the middle box that you say, you have the optimal conditions for transferring the loads of the trains without damaging the ballast or the subsoil. So new sensors enable us to get a better glimpse of how this process of tamping actually works. And I would like to show you this video. Maybe we can play this video. Hopefully you see this. It's a simulation of how the tamping is performed. So the tines go under the sleeper and push up the ballast and loosen up the bedding, which is extremely tight after the usage, to shake it up a little bit and to bring it back into the most perfect condition so it can take the load. Okay, so let's see if we can. So this is how a tamping unit works. So together with the University of Vienna, we designed a project and we wanted to understand better how tamping actually works. We have lots of experience. We are very empirical based, but the answers we got from the experience that we wanted were not satisfying. So we equipped one of our machines with tons of sensors, strain sensors, and analyze the process. And you can see on the left side, you see our mathematical model that we built, and on the right side, you see the results that we get in the field. And it's interesting to see that from the sensors that we got and from the data, we can analyze and detect how much energy and how much energy absorbed by the ballast. And from this, we can derive which ballast, if the ballast is in a good or in a bad condition. So I have a little quiz for you, and maybe you can email me or maybe write me on LinkedIn. And if you can figure out which of the, so there on the right bottom, there are 2 diagrams, and they're both taken. One is taken from a good ballast, and one is taken with old ballast. And if you can figure out which one is the good and which one is the bad ballast and write me the correct answer, I hopefully be able to manage and get a goodie bag for you. So that's a nice quiz at the end of my presentations. I hope you enjoyed it. This is our view, how we see our machines as the working part for the infrastructure providers. Thank you very much.
Christoph, hang on, don't go away for a second. A fantastic presentation. I really loved it. So much enthusiasm and passion, and I felt that you were able in such a short time to transport the exciting nature of what's possible here. People tend to think that tamping and ballast and topics like this are quite dry and possibly even a bit dull, but actually when you think about it, you know, there's an optimal ballast condition, and it's important for every single user of those rails. So whether it's freight assets or in fact passenger assets, you know, the condition of the ride, the experience of those passengers, and also the longevity of the assets themselves, the being usable. I love the version, the description of the 180 kilometers of track as well, and how quickly you're able to achieve something that normally took 60 days, just doing it in 2 nights. It's like a rail hackathon or something. It was super to think about this hype cycle as well, because, you know, we kind of hear these words and we think it's all a bit sort of old fashioned, but actually it does work like this. You know, the technology is coming in waves, and we have to work out where we're going to spend our money, our time, our resources, our collective efforts. So also, you know, there's some pretty specialist stuff there as well. I saw your correlation with the Sentinel and from Matrix, and it did look a little bit like that. Can you just tell me, why has it got the purple lights on it? Is this to do with the cameras?
It's the lighting for the cameras. So during day you don't want to go with the measuring vehicle and wake everyone up because you have very bright lights. So we have infrared cameras mounted on this vehicle at that point of time.
So rail scientists are very considerate people, we've discovered today as well. Yeah. I think obviously one thing that jumped out at me on all of your machinery is incredibly complex. It's doing a really important job, and actually the way that it enables the human to be more effective in their role, to have the right tools, and the interrelationship between the human and machine is almost like poetry. So it makes something very beautiful out of something that a lot of people think is kind of dull and mundane. So thanks so much for your presentation. Let's welcome you back a bit later for the discussion. We get under the surface again from some of these topics. Okay, so yeah, we move onwards now, and we're going to turn our attention to how we could translate IoT into some real concrete use cases. So we're not talking about ballast anymore so much, but we're going to look into 3 specific applications. The switch to improve safety and processes, how location information of assets can reduce costs and failures, and also we're going to look into a specific use case with regards to some lighting. And I think that's the first for Rise of IoT and Big Data at Rail events. I don't think we've talked about lighting before, so we're looking forward to seeing how we can positively impact energy and costs and lifetime there as well. So welcome to the forum from SBB Infrastructure, the Chief Technology Officer, Mr. Roland Moser. Welcome, Roland.
Thank you very much indeed, Daniel, for your kind words and introduction. So yeah, ladies and gentlemen, it's with great pleasure that I present you today 3 IoT cases implemented at the Swiss National Railway Company, SBB. My name is Roland Moser. I'm the newly appointed Head of Technology at SBB, and I'm indeed excited to speak today about this important topic. So without any further ado, we shall have a look at the content of today's talk. Here it is. First, I would like to present you the corporate setup of IoT at SBB, then the first of 3 implemented use cases. Firstly, the integration of construction switches into IoT architecture in order to improve operational safety and reduce outage time. Then I would like to show you how SBB tracks its construction assets and rolling stock and containers. Thirdly, I shed some light on smart lighting control at SBB in order to save on energy and light device lifetime consumptions. IoT at SBB. IoT at SBB is addressed in one of several competence centers. We have a few of them covering what we consider key technologies for our future. This specific one, the IoT for the Center of Competence, COC for IoT, caters for all SBB divisions, be it infrastructure, cargo, passenger traffic, or facilities. This Center of Competence is set up, as you can see, a true one-stop shop, offering support and IoT products from feasibility studies to operation and maintenance of IoT systems. It supports trained technology subject matter experts and the businesses alike, driving the IoT integration into existing SBB assets and provides data aggregations that allow for informed business decisions. So you see here from things over integration into business, the different services that this Center of Competence offers. When it comes to ID generation, consulting, and concept development, they go the full mile. Once it's operation and maintenance, they operate all the assets and maintain them, but leave it to the business to aggregate the data and do the analytics. It offers mainly 3 services. First, it offers various subscription plans of sorts for internal customers to connect their things through what we call the LoRa network. The LoRa Alliance, I trust, is well known to most attendees. It's a low power Internet of Things protocol, and we do this in alliance with other backbones of the Swiss Confederation, namely Swisscom and the Swiss Post. So we have this LoRa Alliance where we share protocols and best practices. The protocol is designed to hook up small battery operated devices, so battery operated things, to the internet, be it on a regional, national, or even global scale. That's the first service. The second service is what we call the tracker service. The SBB IoT Center retrofits existing devices with a variety of standardized tracking devices. So whatever you find you need to track, where you have to know the whereabouts, they are bespoke and standardized services. So they plug a tracker on your asset and you shall never miss it again. Then third is the SBB facility service, offering continuous monitoring of key parameters of staff buildings or staffed containers, key parameters that allow for an optimal asset management, so humidity, temperature, occupation, locking status, and such things. So currently we have above 2,000 IoT devices under management, so more than 2,000 things that transmit whereabouts and status and time series and IO signals in real time or in not so real time. The first use case deals with the IoT integration of smart construction switches. The problem at hand, when you have a construction site and we have to repair tracks or modify tracks, we have to shut down a certain part of the track, avoid regular trains to run through it because we have to work on it. And we will put in a temporary switch that allows for regular trains to circumvent the construction site. Up to now, hitherto, the process was manual and, as you can imagine, prone to human error. And it took time because the first shift by phone and paperwork, they had to announce that they're going to switch, now point the switch from right to left. And at the end of the works, they had to redo this, and of course, prone to human error. The solution we chose is to upgrade, retrofit the rail switches with a IoT device, again through the LoRa protocol. turning such a construction yard switch into an almost regular switch, so you can see it from your operation center and can fully integrate it into the network, which for the time of the construction it indeed is. We also integrated the construction vehicles that we use into the same system, so we can better manage the logistics between construction vehicles and construction sites. The benefits we see are threefold. First and foremost, we mitigate the risk of personal injuries, equipment damage, and of course, if a train goes down the wrong track, massive reputation loss, as you can imagine. So we estimate mitigations above $10 million per year of non-occurred risk. Then we do have leaner and less costly processes. The obsolete manual documentation and process release by phone will lead into an estimated savings of almost $1 million per year. And most importantly, also, besides less personal injuries, of course, the most important consideration for our workers is the reduction of outage time. We have less idle time on the first and last shift, so we can directly start working, as it is very clear if the switch points to the left or to the right. The second use case I'm keen to share with you today is the location information of rolling stock and construction equipment. Here the problem is quite simple, and the solution is also simple and smart, I do hope. We tend not to find stuff in the right time at the right place. This can be containers, toolboxes, containers for people, container with tools that has the right inventory. So we have to find a device that is nearby the construction site, because we have them all over the place, right? And if you just take the next one, you probably get the wrong one. So we have to know which ones are nearest, which ones are fully equipped, operational, and ready to go, field ready to go. This we do again with the LoRa protocol. We equip, for example, containers with key metrics like supplies. We can also then deliver the supplies that are needed directly to site and not to the central arsenal, and then taking from the arsenal to site, also winning time. Also, sometimes people don't quite understand it, but we do spend lots of time finding rolling stock, especially on vast shunting yards. And by equipping cargo rolling stock with a smart tracker wins us precious time when you have to compose new cargo trains within time and budget. So here, these are the benefits that we realized. We have better just-in-time logistics and also better emergency responses when we do have an unforeseen outage and we need tools on site quickly. It is key to know the whereabouts of your tools. Also, we improved the rolling stock detection. Sometimes it's really hard to spot in vast shunting yards, reducing in a massive reduction of process waste and in the process reduction of operational maintenance costs. And the last but not least lighting example is the lightning control. SBB is probably, like many other national railway companies, one of the biggest operators of lighting devices. So the case for SBB, I trust Deutsche Bahn must be about 10 times bigger, but for SBB, we're talking about almost 140,000 lightning devices, 140,000 bulbs that shed light on tracks and stations. So if you want, the enlightening idea was to retrofit them all to allow for remote and automated operations, to switch them on and off, or even dim them, and all this from the comfort of your operation center. with a simple keystroke and not going there. So with a simple keystroke at the speed of light, I suppose. So be assured, all puns are intended. All this, again, via the LoRa protocol. So the benefits we realized at SBB, this stunt allowed SBB to save energy, considerable amount of energy, and also to reduce the hardship of humans and animals living on or near SBB premises and who are in distress of what nowadays is called light pollution. Last but not least, SBB can now focus its maintenance and replacement efforts, thus reducing its maintenance spendings. So this was the third and last use case of IoT at SBB I wanted to share with you today. I hope you found this presentation informative, and I look forward to your questions and discussions. Thank you very much indeed.
Well, Roland, you've just you keep the standard high. Every single presentation today has been fantastic. I'm going to go into a few topics that you've raised. First of all, I feel like it's really nice to see this overview on your competence centre and how you've set it up, because this gives us an insight into this transition between things, the objects themselves, then the integration, and then how we actually make business impact. And I can see why you've done it as a one-stop shop, because this is like the constant issue is, why do you do something? We can all have an idea, and you know, we know that the technology's out there. We've got the sensors, we've got the connectivity, we've got the gateways. The question is, how do we make it valuable? And then I really liked as well the example that you used with the retrofit of the switches, because this takes on that theme, and we go from phone, which is something that characterizes a lot of the supply chain today. People very passionate, they're doing an amazing job, but they have to pick up the phone and call their buddy and ask them whether something's happened, or send something by email. And this is not really a good use of the human. We're not talking about replacing humans. We're talking about giving humans the right tools for them to be more creative and proactive. So I really like this example, and this is an example of true digital transition. You know, to go from that construction yard switch into a regular switch, as you called it, is an amazing achievement. And I don't know if other people have done this. Do you know if has anybody else done this so far, or is this the only case so far of this?
I am not aware, truth be told.
I haven't heard of it.
No. Otherwise, you would have bought it, really.
Yeah, exactly. So you had to invent it because it's not off the shelf. So, okay, then we go into location of mobile assets. And this is a topic very close to my heart. And I have to flash up my trusty globe hopper. So this is the Nexiot gateway device. And actually with SBB, also very close to my heart, because I'm in the Prime Tower. And I watched the grain hoppers traveling to the grain tower in Zurich. The big tower has no windows. It's clearly not a building for people, and it's SBB wagons with our devices fitted on, and they go past me every day with the bing 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 going. So yeah. It's very, very nice to see that. And also, you know, it is amazing that things as big as a rail car could get lost, a rail wagon can get lost, but in the end it's a highly complex system with lots of different infrastructure. So you know, that's just one example that I pick up on. And then finally, as we go into the lighting, I mean, this is, I love your speed of light pun. Actually, it makes us think about how we think these days. We have to manage change at the speed of light. I also pick up on the pun that Christoph mentioned as well, which was shake the box. Yeah, so this is also maybe an example of how we've got to rethink things and how we've got to approach our own business processes and the things that we've been given and handed down in the legacy of the industry. And also it links with Christoph's nicely again, in that you're thinking of light pollution for the poor humans and animals who have to live near rail infrastructure.
Well, Switzerland is a densely populated country, as you're well aware, living in Prime Tower. dwelling in prime tower, so it is an issue indeed.
Exactly, but I mean, it's super that it's obviously hitting, each of these cases hit multiple value points, and one of them is sustainability. And this is also a topic close to my heart because you know, I set up Nexiot to hopefully drive out waste from the supply chain. So I'd like to thank you, Roland. We'll invite you back again shortly, but thanks so much for your contribution there. Yeah, we're getting some good questions coming in already from the audience. So, you know, if you have a question on your mind, anyone who's watching, please feel free to address those. And if you'd like to say your name as well and who you would like to focus the question on, we'll try and get through those questions as well later. So thanks, Roland. Catch you again soon. We go to our fourth speaker now, and we're going to dive into the topic of value-based decision making. The next speaker comes from a slightly different point of view and also a different location, Northern Englander like myself, actually from Yorkshire. But we're going to talk about ISO 55000 and the rail industry. Actually, the economics of investments based on risk and benefits. This gentleman comes from a software and solutions background and has experience from other industries as well, which is also beneficial because, you know, it's not just rail that deals with infrastructure, so utility sectors and so on. We're going to discover how to align our decision making around objectives and also how to acknowledge the constraints. It's going to be super interesting, I know it. Let's welcome the product specialist and solutions consultant from Copperleaf, Mr. Edward Clark. Over to you. Thank you.
Thanks, Dan, for that kind introduction. Just a little bit of background about myself first. I'm actually a civil engineer originally, and you know, I had my first kind of formative years working, you know, building the infrastructure, and then moved into software, and I've had close to 15 years working in the software business, mostly in the asset management space, and as Dan said, within utilities and the rail sector. What I've done is I've split my presentation into two sections. In the first part, I'm going to take a little bit of time to introduce you all to Copperleaf and explain how we are helping the organizations that we work with apply some of the principles of ISO 55000 within their infrastructure businesses and how this helps them deliver value to their stakeholders. So that's the first part. And then in the second part, I'm going to take you through some of the work we're currently doing with Network Rail and look at some of the benefits they're targeting with Copperleaf. So let's get started. So Copperleaf is a global software company with clients spanning 5 continents and covering, as Dan mentioned, you know, several industry segments. We're headquartered in Vancouver, Canada, and that's where our development team sits. The Copperleaf product suite is helping some of the largest and most complex infrastructure businesses use data to maximize value across their investment planning process and build the highest value investment strategies. I'm going to take you through how our approach for this. We've been working in the decision analytics space for over 20 years, and as you might expect for a Canadian company, you know, we started out in electricity within hydro generation, moving into electricity network businesses, and then onto water, oil and gas, and recently the rail sector, as I mentioned, with Network Rail. All of Copperleaf's clients are managing critical infrastructure and making really important investment decisions using Copperleaf. So how do we help them do this? So put simply, we help organizations decide what to do when they don't have enough resources or money to do it all. We use decision analytics to predict the needs of the infrastructure and optimize how that investment plan is put together to meet the business objectives within the constraints that many businesses are operating under. These could be resource constraints, financial constraints, or maybe even availability of the track and so on, as we've heard. The approach we take is underpinned by some of the key principles of ISO 55000. Value is an important concept for us. Value can be released in many forms, whether this is improving the safety of the network, improving reliability, or targeting non-tangible drivers such as brand benefits. we're helping businesses understand the value that the decisions they're making will bring to the organisation. So value is a really important concept within our product, and it's an important part of the ISO 55000 standard. Also, having a line of sight from individual investment decisions to a company objectives is also important and part of the ISO 55000 standard. And this enables companies to plan and achieve their goals and ensures that everyone is pulling in the right direction towards those company goals. And in all infrastructure businesses, doing this and building these plans in a consistent, controlled and governed environment is essential. So as we've heard from other speakers, critical infrastructure businesses are almost overwhelmed with data. There's clearly a proliferation of data in the business. So deciding what to do and why is complex. Data can come from a wide range of different sources, whether it's real-time data showing switch performance or historic data containing details of past failures at signals. One of the key questions is, how do we unpick all of this data to identify key indicators and link this to releasing value through investment in infrastructure? On top of this, the stakeholder environment, if I can just move forward. Thank you. So on top of this, the stakeholder environment, I'll just move forward a couple too many. Just go back one, apologies. So on top of this, the stakeholder environment can be complex. Sorry, Andrew, I think I've got control now. There you go, that's the right slide. So on top of this, there's the additional dimension of the stakeholder environment. Perhaps some of you can recognize this typical boardroom or decision-making situation. Who has the strongest argument? Value to an engineer is different to how the finance director sees things. An engineer may be interested in asset sustainment and minimizing the risk of asset failure across the infrastructure. And the finance guy may be driven to reduce OPEX expenditure. Or perhaps your CEO is interested in maximizing commercial value from the property estate at stations, or is starting to think about hitting net zero targets that are being mandated to him by his government. The key questions here are, how do we get all the stakeholders speaking the same language? How do we communicate the value of risk management to finance and vice versa? How do we decide what to do now and what can wait? In Copperleaf, we do this by deploying an enterprise value framework. Hopefully move on to the next slide, please, Andrew. Thanks. Copperleaf's value framework pulls together the strategic objectives of an organization and understands the KPIs that show how these projects will help deliver these objectives. You can see across the top here some of the strategic objectives of the company, and below these, the individual KPIs, or we call these value measures, that are going to show how a project would deliver those objectives. Copperleaf's solution understands how these KPIs or benefit streams change over time, so the impact of deferring or accelerating a project is understood. Value measures can also be used to drive the behavioural portfolio and the makeup of an investment plan. For example, if you're targeting replacing a specific asset type or targeting certain reliability measures, these indicators could be used as constraints to drive the outcome of the plan. And next slide, please, Andrew. Crucially, value measures are put on the same common monetized scale to enable comparison of different types of investments or solution options. This approach of monetizing risk is used widely across utilities, driven by regulation, and we're starting to see this in the rail sector with the UIC's Asset Management Working Group outlining a value framework-based approach with monetized risk at its core. I was really interested to see hear Roland talking about non-occurred risk around less personal injury and personal damage and how they are considering, monetizing that. The real kind of brilliance and value in the solution, and if you could roll on one, please, Andrew, for me. And the real brilliance and value in the solution comes when you put all of these investment needs, all of these candidate projects together into one place and look to optimize across the whole portfolio, covering different types of disciplines and different types of work. This creates huge opportunity to consider and select alternative solutions or approaches that release funds to maximize value elsewhere within the organization. And as the portfolio progresses through delivery, Copperleaf provides the opportunity to monitor and manage the portfolio, tracking performance and outturn, and possibly even re-optimizing if the delivery situation changes or corporate imperatives shift. The agility that Copperleaf provides across the planning process has been a huge factor for all of our clients being able to quickly rework their investment plans in the current dynamic environment that we're all operating in. So let's move on and now look at how the solution is being deployed at Network Rail. We started to work with Network Rail in May last year. The project, which is currently in flight, is focusing on bringing their Tier 1 asset models into the Copperleaf system. This will enable them to build their 40-year investment plan, and crucially will enable them to look across different discipline types to plan with that cross-discipline thinking. Some of the key benefits areas that Network Rail are targeting, if we could just move forward one, please, Andrew, are in this slide. So transparency. Transparency, thank you. Transparency. So Copperleaf will enable the strategy to be communicated to all stakeholders, with the impact on the infrastructure, risk and key outcomes being fully understood. So create that common framework that all stakeholders understand the value that the investment is going to bring, and it allows people to pivot quickly and making sure that everyone is aligned. Agility, which is the second benefit area. I think we all recognise in the current estate and the current climate that agility is important. Business uncertainty drives the need to replan or reevaluate plans around different situations. Being able to quickly run and assess alternative scenarios within a controlled environment is crucial. This means being able to ask those and crucially answer those what-if questions posed by Network Rail stakeholders. Copperleaf provides that agile planning environment to run these known scenarios, but also prepare for the questions that will be posed in the future, as corporate or government strategy changes. And finally, I mentioned it previously, governance. For critical infrastructure businesses, doing all of this planning and investment planning in a controlled environment is so important, and Network Rail is no different here. Copperleaf provides that confidence that we understand our inputs, we understand those data sources, we understand those key indicators and how they are being used to drive the decision making. Confidence that we're making those informed decisions and trade-offs in that transparent environment. So that's my penultimate slide. Just moving on, I'd like to thank you all for taking the time to listen to my presentation. And if anyone would like to see some of the detail around how we implement this type of solution and some of the concepts I've talked about, please feel free to reach out and contact me on the address here. Thank you, and back to you, Dan.
Thanks so much, Ed. Really cool. Thanks for battling on with the slides there. And, I think we really got a great sense of what your software is doing for your customers. And I'd just like to pick up on a few points as well, if I may. I mean, one thing that struck me is that it's really true that you can't do it all, yeah? I mean, we'd love to, but there's the real world to interact with here, yeah? We've got constraints inherent. We have a legacy in rail in particular. It's not a new system. We're building on top of a legacy. And, obviously there's resource constraints always in any business. Sometimes financial, sometimes practical resources, number of people you have at your disposal and so on. And also, asset availability. If you've got a handful of machines of some sort, then you're limited intrinsically by that. And I think that your focus is exactly right. It's about value. It's about how do we extract the maximum value with what we've got.
Exactly.
And then And then obviously, you know, you mentioned here, we got into the topic of stakeholders, and I think one of the things that jumped out as well for me is that, you know, there's multiple stakeholders whose objectives and desires can be satisfied by the same project, but it's always about communication. And, you know, when we've done these panel discussions before, we've always had this topic of culture, and maybe we'll be able to dive into this a little bit later as well. And I don't think that, you know, we mean kind of the culture that people are resistant to change. It's actually nowadays that everybody wants to do what brings most value, and everyone's kind of fighting for the same resources. How do we make sure that we're focusing in the right places as an organization, but also how do we make sure that as many people's sort of objectives are satisfied by the same project? And you know, when we looked at some of the other presentations about, you know, the lighting, for example, of Roland, you know, you've got the sustainability thing which you're driving, but then you've also got the environmental needs and, you know, sort of the noise pollution, the light pollution, and so on. So, you know, there's all these different things. And then we talk about monitorizing risk, and again, back to Roland's, you know, this non-occurred risk. We see that there's probably in rail sector, there's amazing people doing amazing job every day, which is preventing risk. But, you know, if we can really get a grip on this, then we can know exactly, you know, how much effort and resource needs to be spent in terms of avoiding the risks that you want to avoid most, if I can put it that way. And then as we come into, you know, back to the rail system, as it's a complex system and it's dynamic. And not just that, but in the age of big data, we're learning more all the time about where we can make the biggest improvements. And when you think about the project that Stefan started with, you know, that they were able to do something that would normally mean a section of rail is out of action for 60 days, and did it in 2 nights. And it's incredibly encouraging because it's exponential, this improvement potentially. And with the right software, with the right tools, with the right approach, with the right sensors, with the right minds, people like Christoph, who live and breathe rail and just want to make it better every day since they've been a little boy. You know, it's a really exciting field to be working in, and I can understand why you've transitioned over from utilities into rail, because it's not that different, but there's a lot of things to be done.
There's certainly a lot of commonality there, and that approach around monetizing risk and, you know, delivering value and making those trade-offs as well. You know, how we support, you know, people to make those, you know, investment decisions and compare and contrast, and, you know, make a decision, you know, with that common understanding is really important.
I think that's something that gives me a lot of hope, is that it is cross-disciplinary, and everybody's got something to say. And you know, we sometimes you know, maybe people who are on the practical side of the industry, you know, working with the nuts and bolts, the mechanics, the day-to-day engineering challenges, that their contribution in terms of domain experts is as valuable as anybody else, you know, who's working in the head office with the data. You know, how do we incorporate all of these different expertise into making like huge leaps forward? And we'll dive into this a little bit more in the question session. So thanks, Edward. Thanks so much. Catch up soon.
Thanks, Daniel.
Okay, good. So it's time for a final speaker today, and this is a company that sets a benchmark for data-driven ways of working. And we'll get an insight into the overall vision. We'll zoom into how they go about collecting data and how it's used in the business to drive meaningful change. I spoke to this gentleman in preparation as well, and he's not one to shy away from the challenges associated with these new ways of working. I'm sure it's going to be revealing. I welcome the Manager of Information Innovation, Asset Development, from ProRail in the Netherlands, Mr. Timo Vandenberg. Welcome, and thank you for joining us.
Thank you, Daniel, for having us. And it's nice to talk about ProRail and what we are doing. And hopefully you can see my screen at this moment. I can't see it myself. I brought some slides with me. Let me see if I can see them also. Sorry for this.
Yeah, we can see a screen, Timo.
Oh,
Oh,
really?
now we can't. You've just turned it off.
Digital way of working. One moment, please. Yeah. So I brought some slides with me to share with you. Let me see. Can you see my slides? Sorry.
No, hang on. I have got a copy of your slides, so I'll bring your slides up, and when it comes to doing the image, you can share your screen there.
Yeah.
So just give me 2 seconds.
We're on track, guys, anyway, so we've got plenty of time, don't worry. And I think it's already, you know, we've had a nice relaxed panel and we're on track. So over to you,
Yeah.
Timo. We've got the slides now.
Thank you. I can see them. Well, my name is Timo. I work for ProRail, and we are very happy to join this conference and to talk you through our developments. We can go to the next slide, please. So ProRail wants to become a data-driven company to manage the assets better and to get a better performance. So I brought 2 slides on what we do. So we don't have our own trains like the SBB. We don't have a big network like Germany, but we have one of the densest networks in Europe. And our performance is really high, but still we want to have a higher performance for passengers and rail freight operators. And this is what we do. So maybe we can go to the next slide, because I think that's more interesting, the assets we manage. The managing of our assets is very important. I work for asset management, but also the planning and renewal is done there. And if you use data and advanced analytics and sensoring, we can get even better performance than we do at this moment. I think we have a punctuality of 92%, and we are really proud of it. But at Pro, we also have some challenges for the future. I will get to that later. Next slide, please. Yeah. So this is what we like, what we love. This is a nice picture of our railway network in the Netherlands with our biggest railway operator, the NS. And nothing happens, you think. Yeah, the train is driving and it's on time, but you see many technical objects that they have to perform really good to get a green light and to ride the train perfectly, and to really get the timetable ready. And it's because we have a very busy network, it's important that all assets perform really well, and not only our own assets but also the railway operator assets. Next slide, please. So do we have some challenges? Yes, we have a lot. And the biggest one, I think, is the increase of mobility. Even though there's COVID-19 in the world at this moment, we still think and predict that there will be an increase of 30%, a growth of passengers and freight in 2030. And there are even numbers of 2040 that say an increase of 40%. So that challenges our infrastructure and the way we work and the way we operate. The second one is technology. We see technology as a way to improve our performance, even if there's an increase in mobility. So that's keeping up with technical innovations. And I have some examples in the visual I will show you later. And of course, sustainability. I think what SBB talked about on lightning and reduce energy savings, that's also one of our challenges. So I think we do the same thing in the Netherlands with lightning, but what's interesting is if you look at Europe, many of the questionnaires we are talking about here today are quite similar. And it's interesting if we could work together more than we do now, specifically on data and information. So next slide, please. Yeah, I think this is the last slide. So I would like to now get the how do you say it? I would like to go to my visual on my computer. What we did is we created this visual. I will talk you through it. One moment, show my screen. Can you see the visual?
No, so on the go-to panel, you should see like the big play button. Below that, you've got the drop-down arrow to select which screen that's on. So select the screen. So yeah, we currently can't see it at the moment. There we go. Yeah, it's come up now. So we see this. It's come up now. So we see this.
Sorry for the disturbance. So what we did is we made this visual to create to show all the people within ProRail, but also all the people within the railway industry in the Netherlands, what we mean by becoming a data-driven company. So I'll talk you through it. It's this visual helps us what we want to achieve, but also how it will work. And we're already working on it. So it's not really new, but it's the way forward. So if you look at this, this is the Netherlands on the left corner, and this is the real world in green. And trains are running, and information is used. Data is exchanged between trains and the information systems to run trains. But we also have sensors, of course, IoT sensors, and all that data we want to combine. And we want to process this data, the condition and surveying data, but also the sensor data, to create a digital twin. And to do so, we need to have an information model which helps us to combine those different types of data. So one of the things we are creating is our own information model to really combine different data types and align them so our users can use them to create insights. And depending on the user we're talking to, they want a different type of visualization of the data or the information. So we do 3D data schemes. Sometimes it's simple, like lists or geographical data, but by combining data, it's possible to create a shared view for all our users in our business in the different stages of asset management or projects. You must think about the planning and scheduling of projects, but also the maintenance part of our company, where we create insights in a shared view so we can plan our maintenance. But the same data can be used for designing and engineering new railway structures. And if you have this data, it's always interesting, because with data you can also look into the future. And the planned future with the increase of 30% of trains is interesting. What will happen with our assets and how will they perform? What will their life cycle be? So data helps us to look into the future. if you look at this visual, this is the core part of the way of working, and we thought about how will IoT and data acquisition will help to create this new way of working. So we go to the left of the visual, and we were dreaming about the future. How will the future look like? And we see that there's a big increase of IoT devices in switches, on trains, in embankments. So we see, for example, the fiber optic cables that can be used as a sensor. So there's an increase of sensoring, and all of those sensors we want to use to create insights. And those sensors are, of course, on assets themselves, like on the switch point machines, but also on the trains, on the measurement trains, the Placer trains we just saw in the presentation of Christoph. But we dream of the regular train as a way of looking at our assets. The problem with the measurement trains is that they don't run fast enough, and they only run twice a year. So if we dream about the future, we want to have a train, maybe more trains or regular trains that help us to see and create data for us, which we can use to improve the KPIs. Of course, we also see drones and satellites and other ways of creating data from sensoring. And for example, point clouds are very important at this moment to create more value from. And if we dream about the future, we see that the human in the system that does inspections, for example, will go away. It's much safer also. We think that the airborne and the train and the asset sensors will increase, and we want to be ready for all of them and create insights combining them. And to combine them, we need to have standards to communicate on different levels and combine those data sets. Well, every question we have on acquisition of data has to be mapped on our rules of how do you say it? To create the best way of collecting the data. The data acquisition is necessary, of course, already. And then we go to the right of the visual. The downstream part for our users in the business. They have to monitor the condition of the system and the performance of the assets or the performance of our contractors. And we do it already regularly, daily. We look at how the condition of the assets is and the performance, so we can improve it. But the data is also interesting to create different types of insights. So if you look at the mobility in Europe or in the Netherlands, our data is also used with other parties, because if you can combine data from the railway with, for example, the ports or airports like Schiphol, or the weather, we can create new types of advantages for the total mobility in the Netherlands. And how do we do it? Probably you know of it, but it's for us it's by doing a lot of data science, data analytics or advanced analytics. So we have a data lab, and we have several teams working on creating new insights with data. And sometimes we see that we don't have enough data to create the insights for the future. So one of the things we do is the renewal planning or the prediction of energy. With the increase of 30% of traffic on our network, it's necessary to become more predictive. So it's not only to stop failures, but also to create the best planning of renewal. And sometimes if we do this, not all the times, but sometimes this will create new ways of working. You see it on the right. And that will be implemented in the regular way of working. I can see you, Daniel, so I think my time is up. Hopefully, my presentation helped to create a vision how we do it with Flowrail. Yeah, thank you.
Timo, I've got to say it was a really super presentation and a slightly different approach because if I could maybe pick up on the sort of the things that jumped out on me. We start with the challenges that we face. 30% increase in traffic on an already dense and heavily used network. It's not a small challenge. You know, you can categorize that as a challenge, but to many people that would be almost unsurmountable, you know, to imagine. And then, you know, we can see the trends, the increase in demand for mobility, you know, the increase in use of technology and the integration of that technology and the drive for sustainability. And then you mentioned something that's also very close to my heart, this idea of a digital twin. We hear a lot about digital twins, and just for those people who haven't had sort of an easy or simple description of what a digital twin might be, I'll maybe explain it in a couple of sentences. So as far as I understand, a digital twin is a simulation model that runs in the cloud using data of a real world object, asset or system. So you took it really into a very visual format with this data-driven vision. And I absolutely love this single slide that you showed and the way that you zoomed around onto that slide, because I think we've seen the same topics discussed from different angles now. It's a bit similar to what Ed was talking about, the number of different stakeholders, the different objectives, the possibilities, where you can put the effort, where you can put the energy. And, you know, we all seek to be visionary. Sometimes we're accused of being a little bit too visionary because we have to make it relate to the day-to-day reality of a legacy entrenched industry. But you mentioned the standards, you mentioned the way that we manage it with the data board, with mapping, with data science. It was a very rich and deep presentation, and then bringing it all the way back round to, you know, how we confront this challenge of becoming more predictive as the system demands more from itself, in a sense, with the extra density or the extra traffic. I'd like to invite everybody back now, if we can. We're right on time. We've got half an hour. So if you could all join me, if you could turn your cameras on. We're going to enter our panel discussion phase. And we'd like to keep it flowing. We'd like to focus on improving network availability, extending asset lifetime, and reducing costs. We've got a few questions actually from the audience. I've got some questions prepared as well. Let's just go to a few questions from the audience. I don't know why this is, Stefan. I think there was a lot of interest, early interest from the audience in your presentation. We've got quite a few questions for you, but I think we'll take a perspective from the other people on the panel as well. Let's start with this one. How do we collect the data, and how do we build a reference architecture that goes from sensor to dashboard? And I think that's kind of quite a nice question because it's quite open. We can interpret it in different ways. We can use specific examples, or we can take a high-level view on it. Stefan, seeing as the question's aimed at you, we'll start with you.
I'll aim at a higher discussion ground. We collect the data from the point we installed and mounted the sensors. In the examples I showed you, we connected the sensors to the switch drive inside the interlocking. So it measures the electrical field of the currents flowing through the cables to the switch, and the sensor sends the information of the process of the switch to on the one hand through a cable through our internal network to a data hub, and from the data hub to a standardized dashboard. This is very important. I talked a couple of days ago with a colleague from the UK, and he said he has about 4, 5, 6 different tools to show the current on your dashboard. And we have one, and we have one standardized for all IoT issues we like to push in the future, and that's very good for us.
Thanks, Stefan. I'm going to jump to Roland now, if that's okay. You use the LoRa network, but you also use other networks as well. I mean, I know that you're also using sensors that connect with, you know, the GSM network and so on. How do you? Let's just maybe focus not so much on the getting the sensor data out from the sensor itself, but how do we build a reference architecture? What does a reference architecture mean to you?
Actually, we are currently building a reference architecture around, for existing assets, around this LoRa framework. We do have sensors that communicate over the GSM-R network, and of course the 5G networks of the future. But we see most value in hooking up existing assets, and for that the not too fancy but very efficient LoRa network seems just to fit the bill. We do not need to stream time series of a container really, but the value in knowing the whereabouts and status of these assets and the service status, all this can be fully covered with a relatively simple architecture.
Okay,
these are the low-hanging fruits we're chasing, really.
It makes sense. It depends, obviously, how complex the data is, how much there is, and how often you need it. There's this question of, do you want to do edge computing, or do you want to do the processing of the data in the cloud? We've had to face this challenge as well. If I go to Christoph, I think he is probably representing machinery that collects the most amount of data, just as a guess. How are you handling this topic, Christoph? How do you manage this, you know, building the reference architecture and extracting that data and populating it into your analytics platform?
So first and foremost, I think this discussion kind of relates to kind of, I think, like an orchestra. And I see the infrastructure manager as a conductor, and we provide machines like players, and we are very well in playing exact the tones that you need, but we need to be told what piece we're going to perform. So on our machines, we have capabilities because we are very close to the ground. We can perform in situ measurements. We have lots of energy at storage because we have a large machine to move large things around. So there's enough energy to spare for computation. So I think it's just that our building machines and measuring vehicles are best for edge computing, because we can run a small cloud computer at our machines, so you don't get all the unnecessary data and waste data centers with garbage data collection. We can pre-process them. But I think this is kind of what the trend is right now in the industry, in the IT industry at all, like this edge computing. But it's up to the infrastructure provider to define what piece we are performing and if we're doing an opera or a musical.
I love the analogy, Christoph, there. I actually noticed there was kind of a conductor on Timo's single visual, and you picked up on that as well, I think, Christoph. Timo, there's so many different elements of data collection going on in that single visual. How do you start to understand how you bring that data into a meaningful representation for the software and the decision-making process that Ed was talking about?
Yeah, you really have to work hard to create the insights in the visuals for the users. So we have different systems for the measurement trains, for example, for photos, for IoT sensors. But most of the advanced analytics is done on our cloud platform by data scientists and specialists. And what's nice if they work together. So if there's a real track specialist and a data scientist, they create the insights together. But one of the hardest things is to collect the right data and to really match it and to create the insights. But we do it step by step, and yeah, it's hard work. But when it works, then it's interesting to present your results to a broader audience, and that's what we do. And then we collect feedback and improve it again. So it's a continuous improvement and continuous development of the analytics.
Yeah, you know, that's a great answer, and I've got an experience of this myself, because I love this when going back to the orchestra, when everyone's playing to their strengths, when everyone's able to contribute properly, and that the whole thing comes together into something that's much bigger than the individual parts. And you know, in my own experiences, sometimes we have a situation when we're looking at the data with domain experts, and somebody says, I knew that was happening. I knew that was what was happening for years, but I was never able to prove it. And now we can see it there in front of us for everybody to agree. Yeah? And this is like almost a breakthrough moment where the domain meets the data science. And then the users, the stakeholders, get real benefit because they know that it's evidence-based empirical reality. So let's go to Ed briefly. Ed, there's so many different stakeholders that you've got to keep happy. When you're on this journey with the customer, how do you make sure that the customer is able to integrate that domain knowledge from all of those different participants in that chain, and that the senior level management says, wow, this actually makes sense, this is a single view of my business and I can make the decisions based on this?
So Dan, you've hit on such an important part of this approach of value-based decision making. It's actually, it is a business change element, and you need to take those stakeholders through that process of understanding the KPIs, understanding the value measures, and understanding how they compare and relate to each other, and how you can put them on a common scale. So it's a business change activity, and you get people together and you do it together. That's the approach.
Yeah. So look, when I was talking to Timo in preparation for this, one of the topics that comes up, not just in the preparation, but in every single one of these events that are moderated, is this topic of culture and cultural change, cultural readiness, making sure that people are integrated into this so that you get buy-in, so that people are not isolated and feeling left out of this process, and that we don't leave anyone behind. Now, we're going to talk a little bit more about that in a second, because I think it's a recurring theme. We all agree that we've got the technology, we've got the sensors, we trust the data that's coming from the sensors, we've got the hardware, we've got the gateways, we've got the communication technology, we've got the device management, the data management, we've got this chain that's needed to get this data in, and now it's about how we use it. Is that more or less the case? Roland, I know that you're change program is very sophisticated from my experiences with Anne-Marie Sontag and her team and so on, and you've been a forerunner in this field. How do you start to approach this in terms of gathering together that domain knowledge and making sure that everybody's represented in the process?
Can't hear you, Roland. Sorry.
Yeah, Roland.
Oh, excuse me. I'm good. I'm good. I'm good. Thank you. So I have a second try. That's good.
Yeah. Start again. You.
It's not easy at all, I dare say. You do have the subject matter experts from the railway technology who look after big iron, and then you have incumbents, data analysts, quants from the universities and schools coming in, and they think big data, and bringing these two roles together is not easy at all. It's often I feel that we jump on this bandwagon, literally, and try to hook on things, hook big iron on the internet, and then we forget about that. With big data, we just replace one risk with another, and so we need this holistic view. For the example I brought from the side switches, we engineer out human error and introduce cyber attacks as the threat of cyber error, if I may say. So it's not to have the full picture, and the full business case is still not, at least in my industry, is still not there. There's lots of work to do. Ideally, it's the right team mix between senior railway technology experts and IoT experts, because it's not, they do not come from out of the same mold. Really not. It's maybe not a generation problem. Maybe could be. It's maybe a culture problem also. What is your view?
I agree with you. I think sometimes that we have to try to make people feel more comfortable and that they're more integrated in the project from the beginning, that they don't see the technology as replacing them but enabling them, and that actually their contribution and understanding that comes with lots of years in the business is actually intrinsically valuable. But it's also, humans are not machines. I mean, we are like machines in some senses, but we're not on or off, and we're not yes or no all the time. And I think that we have to recognize that there's kind of a way to interact with the human that needs to be managed. The emotional needs of the human need to be managed and supported. And I guess a great example is Christoph's tamping machine, because you see almost the beautiful harmony between human and machine acting in the middle of the night, going down the track and fixing an age-old problem that rails always had, of maintaining optimal conditions of those rails. And it's something incredible to see. I think anybody who sees that video is going to get emotional, because you can see the progress that's actually being made, and the reason that it's so important as well. Stefan, I have to go back to you again now, because about 3 or 4 people have asked this same question, and that is, what was the most important feature or input or parameter that was included in this rail crossing prediction model? So when you were building that model, and it can go maybe to a more general question, because we're not all dealing with rail crossing prediction, but it's like, how do we choose the right parameters to go into it at the beginning? Because for me, with big data, you don't know what you don't know. Yeah, it sounds ridiculous, but it's really true. Stefan, tackle that one for me if you can.
I would like to connect the answers of Timo and Roland. So on the one side, you have to understand what the data says. You have to get the right experts onto the data and tell them, he has to tell them what the data says. It's a very difficult step to pick the right data, to don't build wrong conclusions. You have to pick the right data. For example, in the railroad crossing prediction algorithm, we put in disorders, opening cycles, train frequencies, degradation parameters, building types and age, and many more. And we use, that's the simple step, I guess, the right statistical method. And we can use many of them which are available over the universities and many companies, but this has to grow, and the steps are one after another, as Timo said, and is at least a continuous improvement progress to deal with the right data, see what they can produce, install it in your system and see what it brings to you. And then you have to correct or increase the right things from it.
Timo's single diagram, I've never seen anything so fantastic in a way, to be honest, because, you know, we really can get a visual on how big the scope of this is. And actually something that you picked up on the end there, Timo, is, you know, it's not that it's just rail on its own. It's actually rail as part of a combined transport strategy. You've got the ports, you've got the passengers, you've got the people arriving on their micro mobility at the rail station. And, you know, you've got ebbs and flows that are all dependent on the time of year and holidays and all kinds of different parameters. How do you tackle this, Timo? Because when I look at that single big picture, it's mind-blowing, isn't it? It's completely overwhelming.
I think it's one of the most beautiful things to work on the mobility as a holistic view. And it's interesting if you can combine data from railway with other types of mobility. So if we predict a failure, but we are not on time and it happens, maybe we can ask Uber drivers or taxis to come to the station and to pick up passengers, for example. And in the port of Rotterdam, we have some really exciting data analytics to create better openings and closings of bridges, for example. So the ships and the railway and the roads combined have a better alternative than now. So I think in future we should use our data more like that. But I still think within ProRail, within the rail industry, we have our own challenges enough. So it's interesting. How do you prioritize all those use cases? And I think we talked about it, Daniel, that it's interesting that the things Stefan and Roland and Christoph and Edward are doing are quite similar all over Europe. So it's interesting if you can combine forces and share knowledge or share insights. So together we could improve more or faster than if we do it all on our own. And I think that would be a nice opportunity, but also I see it's really hard to really realize this way of working, because we also have legal aspects or liability, or so I don't know if we are ready for it. So I'm interested if Stefan or maybe Christoph want to react on that. Yeah.
You know what, Timo, I'm going to jump in. I'm going to come back to that one. I think we're going to end on that topic, because actually, because it's all right, but I really like this topic because it's so important that we collaborate more and that we share more. We find ways to do this. And actually, you know, when you think about this idea of combined transport, I mean, Roland, you know, we've got the beautiful Alps that we're trying to protect from these dreadful road-based transport, you know, modalities. We've got rail, which is 4 to 7 times more efficient from a CO2 and emissions point of view than a road transport. And we've got, you know, why can't rail do the long journey and road do the first and last mile? When you mentioned the Uber case, it's a similar case. We enable passengers to be really delighted to use the rail transport. It's much more pleasant from my point of view. I don't have a car. I'm so happy with SBB. I don't need a car, yeah? But it's true, because, you know, you can do something else on the train and you watch the beautiful scenery and so on, you know. But let's just go to Ed for a second and bring him in a second again.
Just keep on talking. Just keep on talking.
So we'll come back to that one. How do we work better together? But Ed, how do we manage stakeholder expectations? You know, when you've got a whole bunch of stakeholders at the table, they're all making their demands, they're sticking their things onto the board, they're saying we need this or we need that. How do you support that process to prioritize, like with real human beings? It's not just about statistics, is it? It's also about, you know, sort of priorities within that sort of political field.
Yeah, well, I think, you know, Stefan mentioned it early on that, you know, the environment we're operating now within the rail sector is more constrained than ever before. You know, there's the funds are not there. You know, we can't do everything. I think people, the stakeholders, now understand that. So to get to that point that you're talking about is having that common framework that everyone buys into, you know, and going through that process of, you know, running, you know, optimization, understanding the trade-offs that you're making, and understanding actually that trade-off here means I can do something else elsewhere. And that's a kind of common understanding that you get, and that should take your stakeholders on that journey. That's the approach we take. Yeah.
That makes sense. Christoph, when we were talking in preparation for this, we talked about the tamping machine itself is actually, in a sense, it's no longer a tamping machine. I know it does tamping. We know it does great tamping, but it's actually turning into a laboratory, a mobile laboratory in a sense. You've got so many sensors on that thing. Then when we think about Timo's diagram and all of these incredible different ways that we can do sensing as well. So we've got data flowing from everywhere, and you can take your, Stefan, you can take your old infrastructure and you can apply sensors to all kinds of different parameters on that infrastructure, and we can connect it up to our cloud platforms. So let's just talk for a second about product lifecycle management, okay? Because, you know, we're trying to get the most value out of our infrastructure. And to me, it seems like when we're choosing a new bearing or we're choosing a new piece of equipment, whatever it is, you know, we can send the information that we're gathering into the design phase, and we can also send it into the predictive phase to look into the future. So how do we do this effectively? Do people really get this in the industry, or is this just the guys that, you know, like you lot who are standing here today and answering questions about the cutting edge stuff? So, you know, maybe, I don't know who wants to take that one, who feels like it. Christoph, you take it first. We take the tamping machine into a mobile lab. Is that true?
Yes, that's definitely the development. But I think I can answer your question basically with the technology readiness levels that I presented in the beginning. It's we used to railways to be everywhere, and like you said before, Switzerland is the perfect place to live without a car, because why would you bother even taking a car? But all of this is built on constantly improving and building it up. And for new technologies, you have to prove yourself that you can sustain the business case, the business model, and the data around it. So it takes a lot of time. And railways weren't built in a day. We have a system that developed over years. And in Switzerland, it was invested continuously over years. So this is why the SBB has a way better network than any other infrastructure providers, because they continuously invested and invested and invested. Other countries didn't have the luck, so this is why it doesn't perform as good as the others. So with new sensors that we are introducing, they need to develop over the time and to actually be integrated into those systems that have century-long history.
But one thing that we see for sure is that big data brings exponential rewards. Yeah, I mean, the pace of change has been phenomenal. You know, we all give kind of props to the airline industry and things like this, but what I see in rail is it's transformational. I mean, just in 5 years that we've had the rise of IoT and big data in rail events, you know, we've seen massive leaps forward and people much more accepting of using these data-driven models and predictive maintenance and all of the good stuff that comes with that. Ed, you know, you're working a bit with Network Rail. Maybe you can give us an insight into that side of things. You know, how fast are things moving now, especially when you consider that you've got experience from utilities and so on and other industries?
Yeah, I think you're right. You know, and I mentioned it in my slides. There is so much data available. You know, you've all talked about, you know, the sensors that we have all across the infrastructure, but for us it's really important to identify the important elements that are driving the decision making and understand where that is, you know, focus on those areas, because those are the key elements that, you know, really drive the efficiencies and improving, you know, capacity, safety, and so on. So focus on those things that are important, you know, and use that wisely is my advice, and kind of what we've seen across the utility sector as well. Yeah.
So the rate of improvement is directly proportional to the priorities that we focus on, and making sure that we've got the big impact. And I was thinking back to your presentation, Stefan, as well. You know, you're able to make a really big impact by spending hardly any money, and then you get like really some stakeholder interest. You get much more money the second time, and then, you know, you can really shoot off with the same learnings and understanding that you built into that kind of. And often I see it with our own projects. You know, we'd rather know 80%, you know, of something, and that we can investigate further there, and then we can apply more resources. Is that the case for you, Stefan? Do you experience this?
Yes, I guess this is the one or the second, the one or third, second and third step which we have to go to focus on this aim. And the first step is essentially for the next and the third. And we have now a basis for a prediction algorithm where we can build up and connect it with sensor data also. And so you have a very good chance to improve it, or as you said, make an exponential growth and value of the data.
Yeah, so I mean, one of our examples is I've got to thank Roland and his team for this. They actually, sorry, I'll start again. I'd like to thank Roland and his team for one of my experiences with this. We were able to do some experiments on some rail assets, covering them with sensors, and able to determine some real machine learning based examples of impact events and so on. And you know, to actually be able to build enough context around an impact event. If you know 3G happened, it's still kind of irrelevant, because, you know, you don't know enough about what caused it if it's just 3G. But if you have the shock curve and pattern recognition machine learning algorithms working on those shock curve, we take that to the cloud instantly, and we're able to say, oh, you know, this is consistent with something being dropped onto the rail chassis, or it's actually consistent with a derailment or something. Then we can decide to make an automated business process outcome, train the people, make an inspection, and so on. So Timo, back to you for a second. You know, this is machine learning, teaching the machines to do the investigation on their own based on you know, assisted or supported machine learning and so on. Is that something that you're focusing on?
Yeah, a lot. I think there's a lot of data in railway industry already, in the systems we already use, or the sensors or the measuring units, like in Germany, for example. So I think most interesting is, can you create new insights with the same data instead of investing into new sensors? And sometimes you have to invest, I know, but I think there's still a lot to find out in the data we already have, and that's what we do. So most of the effort we put into, yeah, our data scientists and creating the insights from data which we use for different purposes. So and it's interesting. We work together with the market, so with data scientists from the market, but also we have our own data scientists that do the, how do you say it, are the lead data scientists to really achieve the business change. So yeah, I think that's the way forward, to invest in insights and create more information out of the same data. Yeah.
Right, so we've got about 2 minutes left, and that's probably optimistic, but we've got this one last topic to discuss, and that is, you know, hey guys, we've had a great discussion today. I hope you agree with me. I think, you know, it's been certainly the presentations have all been super high standard, and there's been lots of parallels between the different comments. Even though we're all doing different things, we can see that we're on the same track, if you don't mind the pun. So one of the things that Timo and I spoke about in our presentation, in our preparation, was that how can we share better? Okay, there's a culture of working within this new framework within our organizations, but we're all a bit separated, and I can see it around the world. We're siloing ourselves to some degree. We might be working on the same things. We're using algorithms. We've got our own teams of data scientists. We're using the same sorts of sensors. We've got the same connectivity going on, but actually sometimes the ideas stop at the border. At those physical borders between the countries, there's actually a limited sharing. Timo put it very nicely. He said, information's easy to put out there, but hard to find. Okay, and you know, we talked about the fear of transparency. Okay, it's actually a double-edged sword. We all love transparency in this little group, but actually a lot of people hate transparency because it can only demonstrate the weaknesses that they've got in their departments, in their system, in their team. So my question is, my final question, and we can all just have a little go at this one, the wrap up, is how do we share better? What's needed in order to make that happen? Stefan, you go first. Let's just go around the windows.
I guess workshops like that will push these questions to the right people. I guess we have some steps to go, and also technical steps, and also some soft steps due to our regulation. But if we get an initiative where we can put a data lake or something like that in the center, I guess it will not be that, a big problem, because we have national infrastructures, and if everyone shares the algorithms, there won't be any competition between the railways. So I don't find a reason why we shouldn't improve this.
We're only as strong as the weakest link in the chain, and our rail assets go across the border. Yeah, so if Timo does an absolutely fantastic job in the Netherlands, which I'm sure he's going to, with that amazing diagram and sort of single view, you know, obviously it goes over the border to, I won't say which border, but you know, it can go over the border, and if things start to slow down, then it's going to affect Timo's operation too. Edward, how can we borrow from other industries and understand the culture of sharing and the value that brings?
I'm just going to come back to Stefan's point there, because I think that's really interesting. You know, the non-competitive nature of the national railways means that we should be able to share. You know, we should be able to share experiences around, you know, failure conditions on different types of assets, and use that, I suppose, the nuts and bolts of how that actually works and how we make that work in terms of, you know, data lakes or running, you know, advanced learning mechanisms across that data. You know, is not easy, but there doesn't feel like there are any barriers to, you know, real, you know, structural barriers to stopping that happening. Yeah, so I think, you know, discussions like this are a good starting point. You know, the utility sector is a little bit more competitive, so I guess perhaps, you know, there's more opportunity in the rail sector. Yeah. Thanks, Ed.
Timo, what do you think? No single answer, is there?
No, I think it's good if you can share your algorithms in your training sets and maybe part of your data. So other parties or countries can use it. And I know we had a talk with 9 countries last week, and we see that all are quite willing to share their knowledge and their business rules into algorithms. And I know the SBB did it, for example, a lot. And from ProRail perspective, we also do it sometimes, not all the times, but we put some of our algorithms and training sets on the Kaggle website, for example. So if you want to do some convolutional neural networking with images, you can go there and find our algorithms you can use and improve, and hopefully you put it back on Kaggle again. So we also get some benefits from sharing. Yeah. Take the first step, I think. I think that's the answer. Everybody should take a first step, share. Yeah.
Yeah, I agree. Roland, what do you say?
Well, maybe my 2 pennies worth would be, I mean, I like really Stefan's point about the peculiar nature of our business. We do have these entry barriers and we do not compete. I cannot imagine how we would compete in each other's territories. So if not our industry can share best practices, then I do not know what industry can. Maybe Stefan, myself and Timo, coming from more or less national railways, we could meet around the table like Shift to Rail 2, these UIC initiatives, these mighty big state-owned, state-financed initiatives with modest income, I dare say. I'm missing the more informal consortium that you're probably addressing, where we also would have players like Edward and Christoph around the table, and also Nexayot and other players. So I think we should give it a shot, really.
Yeah, well, thank God for this event anyway. At least we could talk about it and plan that and dream about it. Christoph, final words.
So it's difficult to add because very valid points have been taken. So I'll take the chance to wrap everything up. And from the panelists, I would like to thank you, Daniel, and thank you, Ben, for organizing everything, because this is also an aspect that brings us closer together. We exchange ideas, and hopefully when the COVID situation is over, we can have real life conferences. And this is, I think, a very good experience and setup to exchange ideas and get inspiration and to improve on the passion that we are all working on. So thank you, Ben. Thank you, Daniel, for organizing.
Well, I'm not going to try and trump that, Christoph. I really thank you for your contribution. Everybody else as well. I think it's been super discussion. It is challenging, but it's been dynamic. We've covered a lot of topics. All the presentations have been absolutely A1. And I'm very much looking forward to seeing you all in person as soon as it's possible. But let's wrap it up. We've gone 7 minutes over. Not too bad. Super to see you guys. Thanks very much. Thanks to everyone for watching, whoever's been in the audience, and see you all again soon, I hope, for the next event. We've got an event planned for the end of May. Watch out for that. Ben will be updating on that one, but look forward to seeing you all soon. Take care.
Thank you.
Bye.